Hello everyone and welcome back. In this lesson we're going to conclude the implementation of the login functionality. At the end of this lesson you will have a complete solution for user management based on stateful session management. We're going to discuss the pros and the cons of this approach in the end of this lesson. Let's then see how can we implement the attempt login function. The first thing that we need to do is to calculate if the password is valid or not. So we're going to define here a local constant, and we are going to be using, to identify if the password is valid or not, we are going to be using the argon2 library. We're going to be using the verify method that returns a promise. So we're going to add a wait. We're going to call argon2 verify. So the first argument that we want to pass in is the password digest, and the second argument is the password itself. So as a reminder, what this function will do is it's going to extract the per user unique salt that is here available inside the digest. It's going to take the password, take the salt, compute again another digest. It's going to compare both to see does the user really have the correct password, and if so, we need then to establish a user session. Let's first handle the case where the password was not valid. So what should happen here? What we want to do is we want to throw an error that is going to be caught here, and the response is going to be a 403 forbidden without any response body. So in order to throw here an error, we are going to use the throw keyword. We are going to create here an error, and we're simply going to say password invalid. So this information will never reach the attacker at the level of the browser. And this takes care of the situation where the password is incorrect. Now here, on the other hand, if the password is correct, we need to start by creating a session ID. So we are going to take here the creation of the session ID from the create user and session, and we will also be needing to store it here at the level of the session store. So we create here a session. We are going to use again the await keyword to extract here a random number that will be our session, and once that is in place we are going to store it here, and then as the result of this asynchronous function we are going to be returning the session ID. Now because the function is asynchronous, it's marked with the async keyword, this function is going to return a promise. So this promise is going to take this value, and the promise is going to be resolved with the session ID. So the value that we are going to receive here as the result of resolving the promise returned by the attempt login async function, this is going to be the session ID. So we have the session ID available here. So we can do something similar to what was done here at the level of the create user route. We are going to first set the session cookie in the response with these properties, and then we are going to build the response that contains all the necessary user data. This solution would already work and send the correct response to the server. We're going to improve this a little bit and see how the SyncWait syntax allows us to handle asynchronous errors like this one in a synchronous looking way. So let's see what that looks like. We are going to refactor this code block, and we're going to put it here inside another asynchronous function. We are going to call the function that implements this same logic here, login and build response. So inside this asynchronous function we are going to be calling the attempt login function, but this time we are going to do that using the SyncWait syntax. So this function will need similar arguments, plus it's going to need also the response. We are going to pass it here as the last argument. So let's see what this would look like. We are going to take the result of calling attempt login, and we're going to evaluate that promise. The promise will return the session ID, so we're going to await for the resolution of that promise. With the session ID in place, we are going to be building here the response. And if by any chance this throws an error, so let's put this inside the standard try and catch block. If this throws an error, then we are going to handle this error here not by using here a promise catch block, but we are going to use here a synchronous catch block. So this is going to contain the error here, and here the error logic would be to send the 403 back to the client. So as you can see, this no longer uses the then catch promise syntax. We are going to simply do here a call to this function. So as we have seen before, the body of this function definition will be executed because this promise will be resolved. So we need to pass in here the credentials, the user, and the response. And with this in place, we have a compiling program that not only it does not use callbacks, but it's also not using a promise looking syntax neither. This is fully based upon a SyncWait. So before trying this out, let's add here a couple of logging statements so that we can confirm that everything is working as expected. We're going to log this as login successful. And if there's an error here, we're going to simply say login failed, and this will show up in the server log. With this in place, let's try this out. We are going to reload both servers and we are going to head over here to the login screen. Let's quickly create here a new user. Let's keep track here of the server log. As we have restarted the server, let's create from scratch here a new user. So if we hit sign up, this is going to create a user in the database, store its password. Now we are going to log out. This is going to hide here this information, but now we should be able to log in again. Let's try this out. We're going to use the test@gmail.com test email. The password was password10 with capital P. So let's keep track here of the server log. Let's also keep track here of the top menu. If we hit login, we are going to effectively log in the user here at the level of the interface. We have here login successful. We can see the lessons data and we have the logout button displayed as expected. Let's now try to log out. So we no longer have access here to the lessons data. If we refresh the browser, we still don't have access. So let's try this out. Let's introduce here an invalid password like test123. If we hit login, we have here the server information, the login has failed. And if we inspect here the console, we have here a 403 forbidden at a call to /API/login. So the functionality of validating the password is working correctly as expected. If we now introduce the correct password, we should still be able to log in correctly, and that is indeed the case. And with this last part of the puzzle in place, we have a complete solution for user management. We have sign up, login and logout, all based on stateful session management, where the server keeps in memory a token that uniquely identifies a user. Stateful session management is a very popular solution and it's used by many widely used open source libraries. The key benefit for this solution is its simplicity. This is a simple solution that solves the problem very effectively and it's very hard to get this wrong. That is why this solution was adopted by so many popular open source libraries. The storage of the token in memory would in practice never cause us memory performance problems. We would much faster fall into a situation where we find performance problems at the level of our database if we have that many users. So the memory requirements of this solution would never be our bottleneck in practice. Also, it's possible to scale this solution to multiple servers by using a proxy in front of our server with sticky sessions where the requests of one user always go to the same server. This is a well-known and well-understood solution that is very widely used. It's very likely that the application that you are maintaining is based on stateful session management. But we are going to view in the next section of the course an even better solution. We are going to learn stateless session management with JSON Web Tokens. We are going to learn that the login, sign up and logout services do not have to be at the level of our application. We can delegate that to a third-party system, either external to our company or internal, and our application server does not even have to have any sort of connectivity with that third-party server. Let's see how can we implement such solution.